In this video, we're going to look at a few different ways we can use Python to analyze some text. So I've got three different examples of different programs up here along the top. So they're all different and they do different things in different ways, but just to give you an idea of some things we can do. So the first thing we got to look at here is our import. So what is TextBlob? So TextBlob is an API used to analyze textual language. So this is a preloaded package, so you can install it through here. So just go to your manage packages, get your TextBlob up, search it through, and if you don't have it already installed, install it or upgrade it. So from this whole package of TextBlob, we import this part to TextBlob, and we're going to call it TB for short as we use it down through. So then I have my first sentence, my sentence 0, and this here is my TextBlob. So I'm going to analyze this using this TextBlob. So this is just S0, that's just my variable name, it doesn't matter. So being my science teacher that I am, I took the law of conservation of energy, which states that energy cannot be created or destroyed, simply change from one form to another. And I got the new line spacing in there. So then what I do is I get this to print out in S0 the different noun phrases. So it takes S0, it analyzes it using the TextBlob, and it prints out the different noun phases. This one is a bit slow to run, so I did it before I started the video, and the nouns that it finds are energy, states, and energy. So we need to always keep an eye on computers for this kind of thing. They're not perfect, so we need to use our brain as much as anything. So we got to look through and see, have all the persons, places, and things been put in. And for here, for this short sentence, it does seem to be okay. You can do different kind of analysis with it. So you can check for verbs or adverbs or adjectives or different kind of things. So you can analyze any passage of text like that. Another thing you can do is you can get it to print out the different sentences that are in that TextBlob. So here it takes a check through and it prints out two different sentences. So our first sentence is that the law of conservation of energy states, and then it says energy cannot be created or destroyed, simply change from one form to another. So they got two different sentences. Now you might wonder, how can a computer figure out what a sentence is? So one of the ways that it does it is based around this full stop here. So full stop signifies the end of one line and the start of another. If I used a semicolon or a colon here, and if I put that in instead, when I run this same thing, it's only going to detect one sentence, because now I don't have a full stop. So there's just a single sentence here. So that's typically what I'd use for a definition, because that's what comes after. And then I put it on the new line, but I put a full stop in just so you can see the two different lines. So that's something else you can do. So you can figure out how many sentences were in a piece of literature or a book, or if you're a teacher correcting homework. We can also, interestingly, translate our TextBlob. So we have the law of conservation of energy, and we can now get this as scéalga. Siloan an dí maidir le fuinneamh cuimhnú ní féidir fuinneamh blah 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 blah. So we can switch that to Gaeilge very easily. You can pick any other language you like. Take F4 for French, and again you learn the codes as you go through. So then we have the law of conservation of energy translated into French. So again, nice handy way that you can use Python to translate your homework. I'm pretty sure it just sends it up to Google Translate, so you wouldn't need to be online doing it. Another interesting thing we can do is add in different tags. So this tags will take every single word and tell us what it is. Is it a noun, an adjective, or etc, etc, etc. So here I've copied these keys in from my help, I think. So NN means a noun, DT is a determiner, we have a possessive pronoun, gets that symbol there, we have a proper noun, and so on and so on and so on. So if we look at B here, or we look at created, or we look at simply, so see here simply is or be, so that's an adverb. So form, then that's a regular noun rather than the proper noun. So the nouns that it took out earlier were the two proper nouns, which is PPN, and that is energy. So again, NN, and states NNS. So energy, NNP. So we got all the different things we can put on. Again, it's not ideal and might not be perfect, but it's an interesting thing you can do at least. So I'm going to comment this out again. We're nearly finished this first one, so a few different things that we can look at. So now what it can do as well is it can you can look at a text and tell us what language it is. So I have this TextBlob here, so a new TextBlob which says Jetador, and then it'll detect the language that it's printed in. So for this one, Jetador, that's French. So it can detect it and tell us what language it is. So it gives us FR as French. Again, I might need to put a string around it, so this phrase is written in FR and Could translate F4 to French with another way, but again, we're basic here as well. I got another thing here, Dulama, so it's an Irish word. So you got the text blob, An bhfuil ceadagam Dulama go dtí an leithreas máise de hele. So it's a typical phrase you learn in Irish. Can I please use the toilet, basically. An bhfuil ceadagam, do I have permission? Dulama, go out. Go dtí an leithreas, to the toilet, máise de hele, please. So again, we can run this through. So comment out that one, and we can use this to detect what language this thing is written in. So it's written as Gaeilge, so it should return as GA if it does it as it should. So again, that detects the GA. And then finally, we can then translate our sentence, Dulama. So we won't print that anymore because we know it's Irish, so we can translate that to French. So we have this here. So that's the same sentence in French. And to check it, we could also get it to go to Russian or something like that. It has all of the different characters. So it'll see it here. It's got our different characters coming from our ASCII codes. So that's, for those of you who speak better Russian than I, you can see how accurate that is. And as our final tester, we'll pop it into English and see how it goes, and we'll see one issue that arises. So it says, do I have 100 to go to the toilet, please? So that's a pretty close translation. The sentence is, do I have permission to go to the toilet, please? But in Irish, céad means 100 as well as permission. So it is translating it somewhat correctly, but it chose the wrong word. So we would again have to use our brains to figure out what's going on. But again, it's a pretty cool thing that you can use. So you could write anything in English, translate it into French, count your nouns, count your verbs, check how many sentences there are, etc., etc., etc. So there's a lot of stuff we can do with Python. This is a different one here. So again, we have our text blob, and I took the lyrics. So that's my variable. These lyrics, I call them lyrics, so they are lyrics. Is a test blob from a Justin Bieber song called Baby, I think, or Oh Baby, or Baby Baby, or something like that. So we have all the lyrics copied in here. So I just went off to whatever website I got the lyrics on and just copied and pasted the whole thing in here as a string. So I got the lyrics to this Justin Bieber song, Justin Baby. So what we can do then is, and the reason I chose this is I wanted to take a song that has a word in it a number of times. So this Justin Bieber song came to my head. So I'm going to analyze the lyrics, the song up here, and we've got this function of word counts. So we're going to figure out how many times baby is said in the song. So Justin Bieber's vocabulary, it has baby in there 56 times. So not using this thesaurus too much. It detects the language, and despite all of the woes and yas and ohs, it comes back and does figure out that it's in English. You can ignore that bit, that's for something else that we're going to do below. So it detects that it's in English, so then using it. We could also find out the nouns, but again it's a bit slow, so I'll leave it. Another thing that we can use is this thing pandas. So pandas are panel data. So that's a bit more advanced than what we need to get into for the sake of this. But what you can think of is when you see pandas, just think of a table. It's a panel data, which is basically what a table is. You got columns going down and rows going across. So you get your data put into columns and rows. When we're doing a count, and this is what we're going to do here, we're going to figure out what are the most common words in the song. So it's not very interesting if you have all of these kind of prepositions and all that kind of stuff thrown in. So the, and, or, a, is, I, all of that kind of stuff, I don't think that's too interesting. So these kind of words, which are just the common words that you find in anything, they're known as stop words. So I use that variable name as the variable name, or that name as the variable name. So when I'm counting the words, I'm going to leave all of these ones out. So I'm not going to bother counting a or of or to and things like that because they're not too interesting. So then I'm going to create this list of vocab. So I'm going to look at the vocabulary vocab of the Justin Bieber song with the stop words removed. So I'm going to take my lyrics and I'm going to find out which word appears the most often and how many appearances of each word there are. So you could have a question like, is pop music more repetitive than rock music? And then you could do something like this and see if pop music uses the same word over and over a lot more. So then this set again is the define word. So I got lyrics.words.lower, so I put everything into a lowercase so it all match up. And then I have these stop words removed. And again, I could leave, if I decided, in is an important word, I could remove that from my stop words and then it'll count how many times and print out in as we go later on. So again, some of this stuff you can kind of gloss over, so if you get the idea rather than the delivery. So I'm going to put my vocab into a data frame, so that's why it's vocab df, so my vocabulary into a table. This is a thing from pandas, so I'm going to put this into a table, and I'm going to list it according to the words. So I'm going to have words in one column, and I'm going to have the number in the other. So see down here, I've got my word, my vocab, so baby, and then I have my count, which is 56. So baby came up 56 times. So that's my panel data, that's my panda down there. Then for W in vocab, so for every word in vocab, which is, again, vocab is defined up here, it's all of the lyrics in lowercase without the stop words. So for all of those things, I am going to go through, I'm going to find the word, and I'm going to count how many times it's there. Then I'm going to pop this into my panda, and it'll display in the table below. So then then I don't want to print them all out, so I'm going to print out entries with the count of more than 10. So I kind of mess around with this figure. So this figure here, this tells me 10. So it's all the words with a count greater than 10, and I'm going to sort values by count, and it's going to be from top. I want the highest one at the top, so ascending, which means going up, is false, so the biggest one will be at the top, not at the bottom. Then to see it, I print out my vocab. So for this Justin Bieber song without my stop words, it has 56 counts of baby, 24 of I, 17 of you, 17 of O, 14 of like, and so on. Now here's a bit of a problem. It's counted 12 cases of the word inverted comma. So that's not a word, so that's a problem we would have to troubleshoot, and we're going to deal with more troubleshooting in the next one. Again, apostrophe M, there's something going on here, so it's not distinguishing I from I'm apostrophe M. So again, we'd have to do that. So again, Justin came through, so that's probably my fault. When it says who's singing the song, it counts Justin 7 times and Bieber 7 times, so maybe that's something I'd add into my stop words, because he doesn't actually sing, or he doesn't sing his own name, it's just that his name is there. So that's the kind of thing we do always have to use our own brains and not just rely on the computer. So that's why we always got to test these things and just make sure that they're working as they are. But again, if I put some more efforts into it, we will be able to figure out all of these things. We could then change the count here to a word that appears more often. So sorry, that one was 5 when I ran it, so I switched it to 10, but I haven't rerun it. So I can switch it now to 10, so it'll leave out all of these words that appeared 6, 7, 8, and 9 times, and I'll get everything more than 10. So will my appear? So have a think about that while it's running. So we got 56 times baby, EN for language, and it does not print the word. It doesn't, because we have here, we want everything more than 10. If I went for more or equal to 10, then it should print it out again. But again, greater than 10 is just as it says, more than 10. So we can see then we have my put in, because I have greater than or equal to 10. And the last program we're going to look at details a lot of these problems that we dealt with. So we don't want the program to get confused between I'm, which is a word in itself, I am, and then just the typical thing by itself, I. So I'd like to know if it's I or I'm, so that's a bit of a problem to look at. Then we also have this thing of, this is kind of messy to have all of the lyrics in the piece itself. So we have in our code, most of the thing is just the lyrics. So down to line 75, about 70 of those is the lyrics. So that's messy, and then it makes it difficult to work with. If we're dealing with a full novel, we want to have an enormous scroll bar here, and it's going to be difficult to work around. So kind of every problem you have in computer science, there's a solution out there for it. So we're going to take a look at this song next, the Kenny Rogers song, The Gambler. So one of the verses, every gambler knows the secret to surviving is knowing what to throw away and knowing what to keep. Because every hand's a winner and every hand's a loser, and the best that you can hope for is to die in your sleep. So I chose that song last year, so we'll take a look through it again. So that's my text, and I got all of those things here in this WordPad document. It's a text file. So I got a different thing here. I got collections. So again, we don't need to worry too much about these until we have a problem we're looking at. And then from the collections, I'm going to import counter. So this counter will just keep counts. There's different ways to do the word count. So instead of copying and pasting in these lyrics from my text file, I asked the computer to go here and open this. So there's a file. So just call the file, that's my word. But it's going to open this thing here in green, and this in red means it's going to read it. So it's going to look at it and read it. So I give, this is the path to the file, so it's just the gamblerlyrics.txt. So if I look here in my folder, I have my frequency, the gambler frequency generator here. Oh, the wrong way. So that's my file, and then the actual gambler lyrics are here in the text file. So that being in the same folder means I only have to give the short path, so I don't have to give the full address. If I get the properties of this gives me the full address. So if I save it into a different file, I'll need to copy the whole address. But because they're in the same folder, I can just give the file, because the first place it checks is in the same folder. Then if it's not in the same folder, it'll return that it couldn't find it. And if it's not in the same folder, you need to put in the full path for it. Likewise, if I give you this code, which I do, and you try to run it, it's not going to run on your computer because you don't have a file called the gamblerlyrics.txt until you download it. So I don't want to mess around with this file. This is Kenny Rogers' song, so I'm not going to change it. So I have a new variable called lyrics. And into this new variable, I'm going to copy in this string. So it's going to read my file and copy it into this lyrics. So the lyrics become whatever it reads in file. So in this case, the gambler. Then because I'm finished with file, I'm going to close that. So I'm not going to edit it or modify it, because I am going to change the thing as it goes down. I'm going to make it better for the computer to analyze, which would actually be worse for us to read. But I've this now saved in a new thing called lyrics, so the original file will be left. So that's closed, and I can move on. I'm going to comment this out for a sec because it's more interesting to see what happens without it than if it works in the first place. So I'm going to print out lyrics just to see what the song gives us, and I'm going to comment the rest of this out as well, because we got to work our way up to that. So I can print my song and just see that lyrics matches, and it's always a good idea when you're doing these things just to make sure that it works as it should do. So there I got my things copied in just like it's in our file over here. So now I'm going to start my analysis on this, and again, you don't need to get too caught up with the actual code itself, just know that it exists. So I'm going to have C. So from C, it's going to be collections.counter lyrics. So that's going to count all of the different things that I ask it to count, and that's going to have this in the variable of C. I create an empty list for words, and I create an empty list for word count. So again, this is a different way of going about it, but I'm going to take every word, like say for example, if I take gambler, it's going to take the word gambler and add it to the list, and then it's going to figure out how many times the word gambler came out. And you always got to create these before you use them. So next I need to tell the computer what a word is, because the computer doesn't know what a word is. So I'm going to create this new thing called string array. And in this array, which is another word for list, I'm going to take my lyrics and I'm going to split it into separate entries, and those entries are going to be split around anywhere it finds a space, because that's what a word is. A word is contained between spaces. If I delete this here, the computer would then take that as a single word. That's not a single word. We can tell what is a word because a word is between spaces. So I take this and I'm going to split my lyrics into this thing, so it's going to have a whole list of that. So let's just take a look and see what that comes in. So print string underscore array, and we'll just see what that looks like. I'm going to comment out the lyrics up here because I don't want to get it confused. So I'll run this through and we'll see just what this thing does for us. And then we get an error. Name string array is not defined. I can't spell. So it's A-R-R-A-Y. So we'll run it through and we'll see what it does. So it's again got my collections. It took my count for lyrics and then it prints out my string array. So again, that's ran the code below it. So you take all of these words and you see that they're split into separate things. Now here we can see a problem. It's taking this swallow new line character then as a single word, so that's a problem. Likewise here, it's got light and the new line and. Down here, it's got expression new line said. So let's just take a look and see where that comes from. So expression, so find that. So here at the end of the line, it's not finding a space. So because the end of the line you'd hit return for a new line, it's taking this as a single word. So that's a problem. So that's one of the things that we'll deal with later on, but we can spot that problem there. So that's what my string array looks like. So I'll delete that because I'm not using it anymore. Then what it does down is it counts all of the things in string array, Then I have, so yeah, some attempts that didn't work. So then for letter, so everything, I call it letter, really should have called it word. In string array, we have, yeah, that's why I didn't call it word because I'm a list. So for every group in string array, and that list of word I created, I'm going to append in that group, that those letters, that word. And then I am also going to put the count of how many times, so this is the count that it came up. So sum is what would be called a letter. So again, it's a bit confusing, but I didn't want to use word, word, word all the time. So maybe not the best choice. So it takes my two lists that I created above, and it's going to add the group of letters into the word, and it's going to count how many times those group of letters came in. Then at the end, just for us to understand it, we're going to print out the most common words in the song are, then I'm going to pop it onto a new line, and then it's going to give me those 10 most common words in the song. So that was already done down here. So the most common words were to, when, the, no, and, a, for, your, and at. So this is the most common, the 10 most common words in the song, and then it prints out, this is a placeholder for the group of letters, and this is a placeholder for the amount of times it came up. So we have a few problems there to deal with, and we're going to deal with them here in this block of text. So you see this here is a group of text very similar, and what it's used for is it's used to clean text. So I saw that problem where it didn't spot the end of a line. So where this is going to finish it. So in lyrics, it's going to replace every end of line character with a space. So when it finds an end of line character, it's going to put in a space. So that is going to get rid of that problem that we have here. So when we have keep new line chorus, it's going to put that into keep space, find the new line again, another space, and then chorus. But again, for chorus, that's not a word, it's in brackets. So I want to remove those brackets. So for every open square bracket, I put in nothing. So that's an empty one, so that will just delete it. And for every closed one, that's going to delete that too. Everywhere I find the number, I'm going to get rid of the numbers because I'm just not interested in those. I'm going to get rid of full stops because again, full stops will complicate things. Commas I get rid of, hyphens I get rid of, double inverted commas I get rid of. So I'm going to take all of these things out and I'm going to replace it with, mostly just delete it. So delete it with the new line character or replace it with a space. One problem I have though is, and I didn't deal with it before, is if we have a double new line character. So if we have a double new line character, we want a single space, because if we don't, it was actually counting the thing in between. So I'm going to replace this double new line character. So if it finds the double new line character, it's going to replace that with a single space. So that one should work for this. So that's cleaning data. So we find what we want to take out and we can put in instead. We could, if there was a curse word, you could put in the curse word and then add in a different word which would make it more readable for younger people, or you could put in just a series of stars or things like that, so you can just clean it or replace anything you want with anything else. So that's all the same kind of thing, put in over and over again and again. We'd have to look through it ourselves and find our different problems. So if I run this text, it should give me the top 10 most frequent clean words without the data. Now again here, that's the problem, so there's this blank 11 times, so I got still a problem there to troubleshoot. And the lyrics kind of are mostly the same. It's a similar word count to what we had before. But the good thing is that it's cleaner now and we've taken out a lot of our problems. So take a look through some of that, especially this stuff on lyrics. Common error is that you don't have the file in the proper place, or you don't have the proper address. Or as for read, there's also there's read, write, and something else. But read is the one that we'll typically use, and this is a nice clean way to analyze data. So I hope this is viewable and was somewhat interesting, and best of luck.